Thanks for giving this a shot, guys. Hopefully it wasn't too horrible. Now, just remember, the whole point of this isn't for a grade, right? This is to get you ready for the test. So if you're just watching this and you didn't give this a try first, you're kind of wasting your time, okay? Let me mute my audio so you don't get those annoying things all the time. So, like I said, it's a review for the day before the test. That's me. And it's for all my stats periods. So for number one, it's saying a point is randomly chosen on this grid. What is the likelihood that the point is in the shaded section? Remember, it's pretty much shaded over the total, right? So we can just count these ones. This one's not too bad. We have 1, 2, 3, 4, 5, 6 shaded squares out of, we have 4 and 5. So 4 times 5 would be 20 total. We don't even really need to do all this. We can clearly see that this is less than half, right? But certainly it's not 0, so our answer would be unlikely. But this is the reason, right? Because 6 over 20 is less than half, right? 6 is less than half of 20. The human resources manager records the length in hours of one shift at work, creates the probability distribution. What is the probability that a worker chosen at random works at least 8 hours? So this at least is very important. So either 8, 9, or 10, right? So at least. So we're seeing at 8 hours, that's about 0.6 something. We'll say 0.62. We'll say maybe this is, I'm just kind of guessing, right? 0.14, right? If we kind of snake out over here, right? It's a little bit above 0.1, but it's not quite halfway. And this one is definitely below 0.1, right? About, yeah. And so we'll say that's like 0.8. I'm just spitballing here. I'm not exactly sure. So 6.2. Add those three numbers together. We'll see how close we get. Plus 0.8, not 0.8, 0.08. Plus 0.08. Well, 8 plus 62 is 70. 70 plus 0.14 gives us 0.84. So I'll say C. I actually didn't know the answer to that one. So the 0.62 came from this probability right here. The 0.14 came from that probability over there. And the 0.08 came from that probability over here. And when I add those three things together, I get the 0.84. And why did I add those three? It said at least 8, right? So it's got to be at least this one or more, right? So not too bad. Again, you didn't have to get these numbers perfectly. You know, even if you approximated, you still probably get like 0.8. That's a tough one. That's a really tough one. So again, same nosy manager, recording hours. What is the probability that a worker worked 4 hours? Oh. Well, that one's tough. Remember what we said, right? All of these numbers, they need to add up to 1. Add up to 1, right? So if I do 1 minus all of these guys, it's easy when you have a calculator, right? So minus 0.1 minus 0.14 minus 0.3 minus yada yada. Right, all I need to do is subtract from 1, right? So in fact, let me just find a calculator. Let me see if I have one here. So 1 minus 0.1 minus 0.14 minus 0.3 minus 0.36 minus 0.06 equals 0.4. So that missing value right here should be 0.4, okay? Should be 0.4. Remember, these add up to 1, okay? All of these guys right here. All of these need to add up to 1, okay? And then dependent events can best be described as, I won't give you the answer for this one, but I'll tell you this. It's not A or B. Okay? Let's keep moving. So Aaron, Bob, and Charlotte are running a race, which would be considered dependent. I'll tell you, it's not A. Find the one where, find the option where maybe things are getting eliminated. Or options, right? Things are changing, maybe something like that. That's a good way to spot independent events, is when things get eliminated or certain spots get taken up. A 6-sided number cube is rolled twice. Describe, right? So use your words, how you would find the probability of rolling a 5 and then a 3 using a complete sentence, right? Well, I'll just show you the math. I know that I have a 1 in 6 chance of rolling a 5, and I have a 1 in 6 chance of rolling a 3. Right? So what did I do there? What did I do there, right? Maybe like this. Sorry, oops, my bad. Probability of 5, probability of 3, something like that. Come up with a sentence. Tell me what you did. Luca has a bag containing 5 socks. So right off the bat, we know our total is 5, so we have a total of 5. He takes one out of the bag, he replaces it, so we know it's independent. He draws another sock. So what's the probability of a black and then a red? Again, we're going to use that multiplication rule. Find the probability of a black sock and then multiply it by the probability of getting a red sock. And I'll tell you, 5 will be the denominator for both of these, right? So do your number of black socks over the number, times the number of red socks, top times top, and then bottom times bottom, okay? So you should have 25 in your denominator for this one, okay? Abdul and his friends are playing a game by throwing darts on the board to the right. Assuming it lands on the board, what's the likelihood that he'll score at least 10 points? Very important, right? At least 10, yeah? So at least 10, so that means more than 5, right? So it looks like I'm kind of looking at this section. I'm going to use a different color. Yellow is not it. Right, so in this section it looks like we're trying to score, right? Right, either 10, 15, or 20. And, you know, it's hard to say exactly, but it doesn't look unlikely, right? That takes up a pretty good portion. So I'm actually going to go ahead and say likely. You know, I'm not exactly sure off the top of my head, but yeah, I mean, I mean, you know, think about your own point of view, right? I mean, do you think it would really be super difficult to hit a point in that red? And I'm sorry, do you think it'd be super difficult to hit a point in that green section? I don't think so. Okay, only a couple more. So the area of the shaded circle is 78.5. The area of the large circle is 314 square inches. So our desired area is the shaded area. So find the shaded area and put that over the total area, right? I'll give you a hint. The large circle is your total area, so your shaded area should go on top of 314. I don't think I should do the whole thing. And then this one is tough, but you can do it. Let x, we've done similar problems to this before. Let x represent the number of times blue occurs, right? So for example, RR would be like 0 blues, right? Right. RB or BR, that'd be 1 blue, right? And then blue would be, of course, 2 blues, right? It's a 2 here. Should actually write it down. Okay, so we've done a problem very similar to this one. And I can give you a hint, right? We already know that the probability of getting 2 blues, we have 4. We have 4 options, right? So out of the 4 options, I know that one of those, right? One of those would be the 2. So I can tell you that the probability of getting 2 blues would be 1 out of 4, which I think I've said too much. Okay? So as always, you can shoot me a message on Teams if you're having major problems. But yeah, I hope this helps a little bit, and let me know if you got questions, okay?